Forming enterprise data management and analytics with cloud. It looks like a very complex topic, but it isn't. There are just three major components here. The first component is data management, right? Who can identify the second component there? Analytics. And then the third one is what? Are you sure it's cloud or it's with? Cloud. All right. So can anybody just try and see if you could attempt to make a relationship between data management and cloud? Anybody? What's the relationship between data management, cloud? Anyone?
Database storage.
Storage. Okay. Somebody else? Sorry? Scaling. Storage, scaling. So all these they are interconnected. Somebody else? Okay, so we'll take it at storage, we'll take it at scaling there. All right. But we'll take it one after the other, actually. So let's get to the next slide. So this is me. My name is Jimoh Eji Okoh. Jimoh Eji Okoh. When people hear my name, they are most times confused where I'm from. Right? So I want to give you the opportunity to try. Where do you think I'm from? Where do you think I'm from? Who else? Adamawa. Wow. Cross River. China. Yes, that's correct. I'm from China, actually. I don't look Chinese. I don't look Chinese enough. All right, so I'm from Edo State, and I'm surprised. How you got to the first time? How is it easy? Ehi that gave it away. No, it's the Ehi that gave it away. Not necessarily. Okoh you can find. For Okoh you can find. Yeah, Ehi gave it away. I think I should have removed the Ehi from the middle. I think that gave it. I was surprised, like you guys got to the first time. When people hear Jimoh, they are like, no, you are from the north. Somebody says you are from Kogil and all the likes, like you mentioned, right? Okay, so let's go back to the slide. I work as a senior cloud solution architect with Huawei. Sorry, I was asking a lot of questions this section. How many of us know that Huawei has a cloud before now? Did you know? Oh, that means we are doing well. You didn't know, right? But what do you know Huawei for generally? Phones, telecommunications, right? Hardware. So you see, we are almost everywhere. We're actually everywhere. Now we have a cloud. And I work in the cloud department. In fact, I was the very first local employee for the cloud department. All right? So I was the first Nigerian staff for the cloud department. And the cloud is barely almost going to 3 years now that we launched in Nigeria. And we've enjoyed quite some success in this market as well. I did my master's in China, so some of you that said I'm from China, you're correct. I spent some time in China, even though I cannot speak Chinese. That's the crazy part. I can't speak Chinese, but I know I can understand a little bit of, if you say hello right now, I can hear. Yeah, Sheshe. Sheshe is thank you. Okay, all right, so all right, let's take it this way. We are going to use the banking sector as a case study, right? But before I go into this slide, I want to ask one other question. How many of us here are data scientists? Data analysts, data scientists at the back? Data analysts? What if you are just fresh? You are nowhere? Fresh. Okay, so we have a mixed audience, actually. All right, so I'm going to use the banking sector as a case study for this because when you hear enterprise data, we are talking of big data. We are talking of data for enterprises. So that's why I'm going to use the banking sector for this. Now, remember Bank 1.0? Remember the period where you go to bank and they will give you, it's still happening today, but that was where we really started from when we started talking about technology in the banking sector. They'll give you, is it deposit slip? Deposit slip, you want to deposit, you fill the slip and then you go to the counter and deposit, right? And then you want to withdraw, they have what? A withdrawal slip, right? You fill it, and then the bank uses their own internal banking software, right, to manage all of the information. So the kind of data that a bank was getting from us that period was basically data around our transactions. And that's all. And that's the truth. That's all they knew about us. So if tomorrow I decided to leave a bank and go to another bank, they won't really even know why I chose to leave. So that was Bank 1.0. Now we went to Bank 2.0. Back to the slide. Went to Bank 2.0. Under Bank 2.0, we had ATMs. We also had e-banking, which we can call internet banking, right? So there were more data. Agree? The bank had more data. So can you give me an example of the data the bank had in Bank 2.0? What kind of data do you think they had extra from what they had before? Okay. Sorry? So they had information, because there was internet banking, they had information about IP addresses, right? Customer locations. So if I log into my internet banking, they have information about where I'm logging in from, right? They have information about the kind of device I'm using. So if I go to an ATM, for example, and I use my card there, they can tell what ATM that this money was withdrawn from. So they had much more information. Now we went to the era of Bank 3.0, which is where I think we are now, right? Now we had mobile banking, we have USSD, we have fraud detection system, we have, everything is completed basically online right now, right? So they had more information here. Banks began to harness all your information from the internet banking, also from the kind of mobile devices that you use. Also, we talk about the kind of phones, the kind of networks, a lot of other information that they had, right? And now they were able to use that information to build a much more robust system. Now, we now go to Bank 4.0. We are not yet here, but this is where we are going to, where banking is powered by AI and machine learning. Essentially, the kind of information that will be gotten here will no longer be used actually for anything but just to make predictive analysis. So they are making predictions. They are trying to guess, what are you going to do next? So they have a complete profile about you, and they're looking at what you're going to do next. So the beautiful thing about all of these different stages is that data is being generated across all of them. So as we began to progress from 1.0 to 2.0 to 3.0 to 4.0, the banks had more and more data. This doesn't just apply to banking, it applies to every other sector, right? There is innovation happening in every other sector, and data is being generated massively. Now, a major question comes. All this data that has been generated, what is being done with them? Let's go back to the slide. Right, so let's get into here, the source power of data in banking. So like I said, I'm going to use banking as a reference. Now, across each of those four different stages, there were data being generated. Now, you look at the banking sector today, we have what we call the core banking systems, right? We have integrations. So you want to integrate with third-party providers like switching companies, NIPS. You want to integrate with InterSwitch. You want to integrate with other third-party organizations. You have channels, ATMs. You have mobile applications. All of these different sources are sources of data. And then it grows. Look at all of this up here. Some people go to banks to take loans, right? Banks have ERP. Banks do KYC. Banks have ATM. Banks have call centers. Bank work with vendors. They have a car park. They have a CCTV. When you go into the banking environment, the cameras take the footages of you. They keep a profile of it and all of that. Now you begin to ask yourself, what do they do with all of this data? Right? How can they make meaningful insight of all of this data? And you can see all the data are all interconnected. So let's say you are a customer with a bank. You have an account with a bank. And then you walk into the banking hall. They have a profile of you from their CCTV footages. They had an event. Let's say they had an event for kids, for example, where you brought your kids to come and have fun. So they have records about those events. They have the names of your kids now. And then they have information about the kind of fun activities that your kid engaged in, that your kid likes this kind of activities and all of that. So how do they make sense of all of this data? So this is essentially what we call big data. So it is massive data about just one person. And take all of this information about millions of customers that they have everywhere. So how do they begin to harness all of this information? Now, this information that they harness, they want to be able to use it to provide much more satisfaction for you. They want to give you a very robust user experience. They want to be able to sell more. There was an event, by the way, that's my wife there. There was an event we had, right? There was an event we had, one of the banks that we bank with had last year, and she's been disturbing me this year. When is this bank having this event again? You know? So they want to be able to sell more. One thing that should happen with that event is that they sent me the email, and I forwarded to her. She went with the kids, that was last year, and they got her to sign up, right? So they had the proof, they had the information from me, and they were able to use it to convert it to sales, right? So they use all this data for all of these different experiences. They also use it to make decisions, real-time decisions about different things in the banking environment. So how does all of this data that the banks or any organization collects, derives value for them? So we have what we call the 5 V's of data. Volume. Number one is that data has volume. Data has size, right? Data is like water. So you start with a cup of water. Before you know, they said tiny drops make an ocean, right? You have a bucket of water, then you have a basin of water. Before you know, you have an ocean, right? So data has volume. That means it has size. So as the data begins to grow, the size begins to grow. Data has value. There is something data can tell you. Data can help you make meaningful decisions. Then data has variety. There are different varieties of data. Who can give me the different types? We have PDF, right? We have what? We have what? CSV. We have video, right? We have audio. We have even paper. When somebody gives you, one of those customer agents gives you a feedback form to fill, that's data for the bank. True or false? All right. Then we have, what else? What different format do we have again? We have SQL formats, right? Yeah, we have surveys as well. We have TST format. There are different formats, so there is different varieties. So part of the V's for data, the third V there is variety. Now we have velocity. Velocity simply means how often does this data come in, right? So we are talking about right now where you go to a banking environment to withdraw money, and in that process you decide to sign up for a DOM account, and before you know, you decide to send money to somebody. Now, this is data you are giving back to the bank. How often does that data flow? So there's what we call streaming data. These are data that is always coming in, per second. Social media data. We forgot to mention that under variety. There is social media data. The banks today, right now, pay attention to social media. You are coming to the bank to get loan, for example. They want to get as much information from you as possible. There you have social media footprints. These are data that can help them, be able to make decisions about you. So they want to get a 360-degree profile of who you are. I mean, you can come to the bank and bring all of the documents, and while on social media, you are saying, if I ever pay back this bank, make I die. Do you understand? So they want to be able to know who you are. So all of this data, they are very important to them. So these are the variety of data, and that's the velocity of data. Then finally, veracity. Now, there is no point having all of this data at the end of the day without data being truthful to you. So what's the point of having data that lies to you, that tells you that this person is a fraudster, meanwhile this person is not a fraudster? So that's wrong. So these are the 5 V's of data. So let's go ahead. We have a long way to go, and I want to be as fast as possible. So data as a game changer to drive any business. So let's not limit it to just banking, right? This is any business at all. It could be your career, it could be anything, whatever data points that you are gathering, what value does it give to you? Number one is to understand the customer's behavior and preference. And that is the first thing I talked about just now, when I mentioned the fact that banks also use social media data. They want to understand your behavior, they want to understand your preference. If the bank can have enough data about me to understand that I like egusi soup, I will tell you that they will keep showing me offers that would make me, come to bank with them, especially since they know that I like egusi soup. So they can want to run personalized marketing and promotions, right? And then again, data can tell them about customer retention and churn analysis. Who knows what this means? Churn analysis means, sorry? What is making people leave? You understand? So let's say somebody, can we find a very valid example? So let's say somebody, okay, I don't want to mention names. We all know the bank, right? It happened recently, right? We know the bank, right? So I don't want to mention names, right? So let's say during the period where what happened, a lot of persons changed their bank to a different bank, right? That's data for them. So they want to know what triggered, why are people leaving? If it was before, they might not know. They might just feel like, okay, maybe people are, they won't even have any information. They won't have any real insight. It's maybe only when they care, they begin to get information about people, the numbers of transactions have reduced. But today, they can get it real time. They can see per minute, per hour, down to even per day, what the volume of transaction happening in the banking environment is. So they want to be able to know that information. Can we go back to the slide? Can we go back to the slide? All right. And then operational efficiency. You know what this means? Let's say they are looking at increasing the number of bank branches as well. They can't just wake up in the morning and say, okay, we don't have a branch in Nnewi, let's go and put a branch there. It doesn't work that way, right? It's going to come from data. Data will tell them that there are some people in Nnewi who are using the bank. So let's assume that there is some deposits coming from the location Nnewi, and they don't have a bank branch there, right? When they analyze the data and they see the volume of transaction, they see maybe the top 10 transactions, and they see that about 8 of them is coming from Nnewi, and they don't have a branch there. What would they do? They make that decision and say, we are going to have a branch in Nnewi. So this is data-driven decision-making processes as well. Enhanced risk management and all of this. So let's get into it. Now, this is where I want to start really talking about my topic today. So this is actually evolution of the data management platform. Let's remove the analysis there, right? Evolution of the data management platform. Let's begin to look at what platforms can we use to manage data. So we have a lot of data right now, right? We're using the banking sector as an example. So much data about just one person. So much data. Now, how do we manage this, right? All right, before I go into this, I want to begin to break it down for some of us who are new to this concept. Right, so what is the very basic unit of managing or storing data? Who knows? Basic platform for storing data. Okay? Database. So what's a database? All right. So what's a database? A database is a platform where you store data. It's as very simple as that, right? But it has to be structured data. The key word there is structured. So it has a defined pattern, right? So it could be a relational database where, like you mentioned, like a spreadsheet, right? You have the name of the person, you have maybe the phone number, the account number, and all of that. And then maybe in another different table, you have the account transactions. So you can relate that account transaction table to the table containing the name. So a customer table and a transaction table, right? So this is a database, right? And sometimes a database may not be relational. What it means is that it may not be in a table format. It could just be in a format where it is still understandable. It could be, how many of us are heard of JSON format? It could be a JSON format where you just have key value pairs, right? Name, column, Jimoh, occupation, architect, and all of that. So it could be that. But it's just a platform for storing data. Now, another key component of database that you also need to know is that databases are what we call OLTP based. You know what that means? Online transaction processing. Right? It simply means that it's just your everyday dump data, get data, dump data, get data, right? If you attempt to decide to query that data to get more information about something, you might likely slow it down. So because that was not enough for enterprises to be able to get meaningful information for what they are looking for, that gave birth to what we call data warehouse. All right? So a data warehouse is essentially a collection of multiple databases. Let me give you an example. A bank today, most of the banks you know today, they run pension, right? Many of the banks today, they run insurance as well, and they have their banking services. Now, they have different apps for all of these different business units, right? So I might be a banking customer without being a pension customer for them. Is that correct? I might also just be a regular banking customer for them without using their pension product, right? So that means they might have my name in one of their database, Jimoh, all my transactions, but when it goes to the pension arm, they don't have any profile of me. Is that correct? Now, likewise, it might also be you. You use 3 of their products. Maybe you have a banking profile, you have an insurance profile, then you have a pension profile. That means in each of those 3 different tables or 3 different databases, your name is there, right? So now, if they ever need to get information and say, how many of our customers use the 3 of our products? Or how many of our customers, or who is the most active customer within our own business environment? They need to be able to do what we call analysis, right? This is not just transaction. This is not just, transaction in this term actually doesn't mean money. It means where you just get information, store information. But they need to get more information about you. Or, not necessarily you, they don't know you, but they need to get information about the users from the system who is involved in 3 of their different businesses. That is where you start doing analysis. They want to get more information, right? And this is where the data warehouse concept comes in. Because one single database is no longer enough. They need to be able to bring the information from this database into somewhere. Bring the information from the next database into another place, into the same place. Then the 3rd, the 4th, the 5th into the same place, in a format that they can be able to make meaningful insights or get meaningful insights from, all right? Now, a data warehouse, look at it like the way you have a standard warehouse. You bring in goods, right? Before those goods come in, you must have packaged them, arrange them in a format. So before you're able to bring data from a database into a data warehouse, you must have gone through what we call an ETL process, right? Who knows what an ETL is? So you must have gone through an ETL process, right? So you extract the data, you transform it, right? So there are different ways of transforming data. You could do aggregation, you could do normalization, there are different ways, and then you load it into the warehouse service, right? So it goes through all of those processes. Now, the truth is that since 2000, year 2000, when we entered the era of Bank 2.0 and 3.0, a lot of businesses have maintained data warehouse solutions. And it's helping them make good business decisions. But you see that slide I just showed you right now that says traditional data warehouse cannot meet data analysis trend. Who knows why? Without looking at the slide. Categorically tell me one reason why data warehouse is not enough today. Sorry? So you guys are not looking at the slide. It's there. All right? You said? Okay. All right. So let's go back there. You are right. Now, the reason is because the data that is still going to the data warehouse is structured data. Because it's your database that is feeding it. Like I mentioned earlier, database usually consists of what? Structured data. So it means it has a particular format. Right? So, but today, you agree with me that the data we have in this world today, I want to use the word, is just anyhow. Right? More than, as you can see here, more than 80% of this data are unstructured. So it means it doesn't have any particular known formats. Right? I'll give you an example. The example I gave to you about a customer who wants to take a loan, right? He's coming with his documents to the bank and then goes to social media and say, if I ever pay this money, make I die. What structure is that? I mean, he's just writing a random article anywhere, right? So now we also go back. What of a customer who goes and make a video of himself on TikTok streaming live, right? What structure is that? It doesn't follow the conventional database format, right? So these are all of the information that we have today. By the way, just to digress a little bit, the reason why you see content creation will always be there tomorrow is because data continues to grow. So content will always be there. There are new topics, new stuff that will contribute to data growth tomorrow, right? So videos, you want to extract audios. You had a customer, let's say you called the customer care in the bank and you spoke to them. I don't like the way you guys are treating me. I mean, I've transferred money since yesterday. I've not gotten it. They have recorded that call. They recorded that call. That call needs to go into somewhere, right? And that call is unstructured because it doesn't fit into the format of the database. And why do they need to keep that call? Because tomorrow, maybe there are certain pain points that you have that by the time they listen to all of those calls from 10 other customers, they can discover where they are messing up. Agreed? So that's a very vital information that they need. So traditional data warehouse, like you see here, cannot meet it because most of the data that we need today are not in the format that can be supported by traditional data warehouse. And again, we are moving away from, I'll talk about data warehouses in a bit, right? I'll tell you what it is and what it can do and what you can get from it. But it does not necessarily provide full support for predictive analysis. Now, there is what we call statistical analysis, as you can see here, which is analyzing or making decisions based on historical information, right? Something that has happened, right? And there is predictive analysis. Essentially, this is something that has not happened. But the data is telling you that this thing might happen based on the trend, right? For some of us that do trade forex here, right? You see that the line is going up, and then you see, it's most likely that it will go up next year, right? So that's predictive analysis. And you cannot use data from data warehouse to do that because it is just data from a limited set of data. Right. So this is the reason why it cannot meet. So let's go ahead. So I'm going to skip this. All right. So let's take a look again at where I want us to get to. Because where I want us to get to is not even data warehouse. Now, this is data warehouse that we just looked at. And this is the concept I just described to you. If you look at it, these are databases. These are regular databases. Through the ETL process fed into the data warehouse. Right. And like I mentioned, in the early 2000s, this is what a lot of enterprises are running, right? But they soon realized that there are other data that cannot fit into this, like I already mentioned. And then the next generation was born, which is what we call the data lake, right? So who can tell me the quick difference between a data warehouse and a lake? I think we've already talked about it. Anyone? A lake can store both structured and unstructured. All right. So that's a very important answer. That's the correct answer. All right. So the data lake was born, right? So the data lake provided enterprises with a platform to store both structured, as you can see here, and unstructured data as well. But this was data lake generation 1. The issue with this phase was that organizations were desperate to get as much data as they wanted because now we had unstructured data. They wanted to get it. So they ended up storing this in local drives, just the way you would have your on-prem servers, right? So they will buy an on-prem server and they will decide to harness all this information. Let's just dump it there. Now, the issue with that was that they spent more time managing those servers than getting insights from them. Right? So you had to hire a dedicated team that would manage the infrastructure. And there was a lot of wastages. That was the slide I skipped. There was a lot of wastages because you would buy a huge amount of server and you want to run some big data components on it. You will end up, with very massive cores, very massive memory, and then maybe the storage layer being underutilized. So there were wastages as well. Now, because of this challenge, the cloud saw an opportunity. People like us, Huawei Cloud, we also saw an opportunity and we said, okay, this is the trend. Let's help these guys out. So this was the era generation 2. This is actually where we still are now, right? Still alone. Sorry. Okay, so this is where we are today. So the cloud, I believe the AWS guys who came in before must have. I don't know what the guys talked about, but this is basically where we are today with data lake, right? So you had the cloud-powered data lake, right? A lot of data, big data components like Flint, Presto, all of these were provided by platforms such as Huawei Cloud, right? Now, let me tell you the challenge with this. The challenge with this was that, yes, it met the need of data having structured and unstructured data. It took away the stress from enterprises managing it themselves. So instead of you spending time trying to manage infrastructure, just focus on running the big data components on it and getting your insight. But the challenge is that at the end of the day, from this data lake, you still want to be able to, clean the data up. This is where our data scientists in the house come in. Clean the data up, prepare the data to a format that can be read by your BI and your other tools, right? And what happens is that because you want to move this from a lake to a warehouse, you're going to have duplicate data. So you have data residing in the lake, and then you clean it up, move it to a warehouse where it is more structured before you want to read from it. So the issue became that you had duplicate data. Now, that led us to the third generation. And who knows what that generation is? You're not far from it. It's called a lake house, right? So a lake house is a combination. That's what you see on top there. So a lake house is a combination of data warehouse and a data lake. Actually, the singular reason why lake house was invented is to solve the problem here, which was copying data from the lake again to a warehouse. So this would simply serve as just one converged engine for a lake and a warehouse. Clean the data there, get the meaningful insight from the data there, all in one place, right? And this era led us to the AI era as well. So since the data was all in one place, you didn't want to have copies of data somewhere else. So why not just bring AI functionality to that same environment? And then that's where we are here, right? All right, so data AI convergence has become industry standard. There are topics today such as data lake, lake house, data mesh, and data fabric. These are very interesting topics for some of us who are in this data space. So a lake house, like I mentioned, is a hybrid of a warehouse and a lake, right? Data mesh. So since you're going to have, sorry, please, can we have the door shut so that we can focus? So since we are now going to have all of them centralized in one place, the concept of data mesh and data fabric came into play. Data mesh simply means that how do we share data? Now we have a massive pool, a lake house where we have unstructured and structured data, clean data. How do we share this data? So data mesh introduced the topic, the concept of bringing down decentralizing data essentially, so that the departments who are responsible for the data can have full ownership of that data. Data fabric, on the other hand, brought in the concept of how do we access the data, right? So these are two very important topics, and this is the convergence of data and AI today as we have it. All right. Okay, I'm just going to skip this slide. So I'm going to talk about what Huawei Cloud is doing. All right. So this is Huawei Cloud. So at the very base, like I mentioned, the lake house concept runs on what we call a unified storage. So it means that storage will serve as a warehouse. That storage will also serve as a lake as well. So you can dump all kinds of data here. So at the very base, you have unified storage. And we have a service that implements this today. It's called OBS, right? For some of you guys that are very familiar with AWS, you know S3, right? So OBS on our own is a more optimized version of S3. So can serve for any kind of file format, both structured and unstructured. And it's a distributed file system as well, because you can have the same objects duplicated in several different systems as well, all right? So the foundation there, like I showed you, is powered by OBS. All right, and this is the core about Lakehouse, a unified storage. So all of those concepts of copying data again from lake to warehouse was totally eliminated. So the next level, on top of it, we have what we call converged computing engines. All right, so here you want to bring your data warehouse components. You want to bring your big data components. I'm going to talk about some of this in a bit. You want to bring what we call cloud search. Some of you know Elasticsearch. You know Elasticsearch? So we'll bring in those concepts, and we also bring in machine learning capabilities as well here. All right? Now, please go ahead. It's based on Postgres. Yes. It's based on Postgres. All right. Sorry, next. All right. So on top of that, we have two other aspects which are very important. We have what we call the data arts. So data arts provides you an end-to-end data lifecycle management. So when you hear about data governance and all of that, all of these are services that we have on top of the Lakehouse. So you can do all of your data governance here. And also on the right-hand side, you have your machine learning capabilities here, which we call the model arts. And then on top of it, you can use the end result for statistical and predictive analysis. All right, so this is how Huawei Cloud today has developed a Lakehouse and develops Lakehouse for customers around the world. Now, because of time, I know she's coming for the second time. I'm just going to quickly skip this. Yeah, don't worry. I'll quickly skip some of these topics, but I will leave us with where to get more information from them. We have the data warehouse itself. This is an enterprise-grade analytical database service, actually. So this is one of the components that makes up the Converge engine I showed you here, right? So we have different data nodes that works at the same time processing and analyzing your data for you. So it's very scalable and has a very high performance. And then we also have a serverless version of it. So you can see if you need to run analytics and you are running it at 8 a.m. and this is the size of data, the size of analytics you need to get out from it, you only pay for what you use. For when you don't use it, it's not billed at all. And then we have the MapReduce service. This is based on Hadoop. So many of us know Hadoop here. You know your big data component. So you can choose to use either MapReduce, to use Spark, or to use Flink, and all of this. Then the storage layer, like I mentioned, is actually based on OBS. You can also choose to use HDFS. So this is 100% open source compatible. And then one of the major things that we've done differently here is that we separated the compute and the storage layer. So it means that you can scale any of those layers independently to save you money. So you don't need to buy a cluster with the compute and storage coupled together. You need more computing resources. You are increasing storage. No, you can decouple them essentially. Now, how do we compare with open source equivalents? For Hadoop, we have our MROS Hadoop here. It offers you 3 times better performance. For Hive, you can get 4 times better performance. For Spark, you can get 2 times better performance. For Kafka, you can get improvements on the equivalent on Huawei Cloud part as well. Now, the data lake insight is similar to our MROS, but just that this is serverless, right? So these are Hadoop-based clusters as well, but you don't need to manage them yourself. They are purely serverless, right? And then we have the what we call the cloud search service, which is based on open source Elasticsearch. Now, the interesting thing about this is that it can retrieve rich text as images. So you can, even though you have images, you have pictures, you have videos within your data lake, you are able to retrieve rich text from them as well. Then you're also able to work with natural language processing to provide semantic understanding. Let's say you are searching for something like book, for example, from your data lake or your data warehouse. And then working with natural language processing, it can get similar meanings from it and then provide you that in that context as well. Now, this is Data Art Studio. So within the data lake itself, I talked about Data Art Studio, right? So this is where you can build an efficient data pipeline, essentially. Define data governance rules as well, and be able to also manage data security as well. So there are sensitive data that should not be exposed. You know, today we give banks all of our data. They ask for BVN, you give BVN. A bank that is doing insurance might want to share your information with their insurance arm as well. So how do you, within the organization, ensure that only the relevant information is shared to departments that need it? So this is where end-to-end data management lifecycle comes in. And on Huawei Cloud, all of these are bundled together with the Lakehouse as well. Then you have model art as well. Like I mentioned, the model art is the machine learning arm of it, right? So it brings you to different components on the platform. So you have a data processing, data labeling, data training, algorithm development, model management, and then finally for model deployment, you can use that to feed your apps or whatever output you're looking at doing that with. All right. Now, I'll just talk about this slide, and I will share the next slide. I think that will be before I go to the last 2 slides. Now, what are the advantages that the Huawei Data AI Convergence Platform, which is more like the Lakehouse, will bring to you? Number 1 is that it eliminates data silos. Like I mentioned, instead of maintaining multiple sources of data within your organization, you just have a single source of truth, right? A unified storage system where The data is unified there, and then whatever operations you need to run against the data, you can run it there. Now, it provides you with extreme performance. Like I mentioned in one of the services we provide, it comes with what we call a multiple parallel processing engine. That means it can handle concurrent tasks at the same time. And then I also talk about storage, compute decoupling. It is fully based on open source, all right? So all of those open source that you know already, it's fully based on them. And then we can provide you very robust support. So I want us to look at this image here. So I will talk about this image and then this architecture, and then we'll have 2 more slides and we are done. All right, so this is what our proposed data lake house implementation for organizations will look like, right? So with what I've explained so far, I believe that this is straightforward, right? So let me quickly explain it. So these are your data sources. So still using the banking environment, these are your core systems, your CRM systems, every POS transactions, all of these can be injected through this layer. So we have our data migration service. You can also use Kafka as for real-time event streaming as well from your data sources. Then we have the big data cloud data migration tool here. So this ingestion layer feeds your data from a data source into your data storage. I already mentioned that our storage is empowered by OBS, as you can see here, right? And then from OBS, you need to process the data. This is the data lake here. So this is the data lake here. You need to process the data. You can run the data against MROS here, which I've talked about. So you can use any of the big data components like Hadoop or Spark. And then by the time you've done all the processing, then you have your data governance tools here. So you can do all of your data cleaning, maintain data quality, enforce data governance rules here. And then you can store your data in the data warehouse. Now that your data is here, it is available for analytical purposes as well. So from here, you can plug it to your BI or reporting tools. Or if you don't want to take it through here, you can pass it directly from here down to your AI engine, where model art comes in play. So here, you can use it to train your models and then do other kind of inference or pass it down to a consumer app and all of that. Everything is within the Huawei cloud ecosystem. So we have developed our own IDE. Yeah, we develop our own IDE. So within the ecosystem, where you deploy your MapReduce service, you can use the IDE within the system here. Yes. Yes. All right, next slide. All right, so the lake house is used by more than 3,000 customers today around the world, across 60 countries. I'm going to just talk about some of them. We deployed this same architecture I just showed you to one of our customers, NewGrid. NewGrid is more like, you know what Temu is doing today? How many of you have, you know Temu, right? You know Temu, right? Many of you guys don't know Temu yet. You know Temu. So after they spent more than 2 billion, you guys still don't know them? You know them, right? Okay, so many of you guys don't know them yet. I mean, they are all over the place, right? So essentially what NewGrid does is that they collect data from retailers, manufacturers, and then they provide the product from these manufacturers and retailers down to their end users. So they have a lot of data coming from REST APIs here. All right, so this data is fed into the data storage layer, the same architecture I showed you earlier. Now, this is the advantage that they enjoyed. All right, so this is... All right, so this is the advantage that they enjoyed. Now, before now, a file processing for them would take 7 hours. To the end result that they are looking at, which is the TDE file, that will save them more than 40% as well. So this was the performance results derived from using Huawei Lakehouse as well. Also for ICBC, ICBC is the world's largest bank by assets. I don't know if you know that. All right, so the world's biggest bank by assets.
Now, before now, they could only engage 2,000 concurrent analysts on the platform.